Does anyone did anyone stop recording? How recording got stopped? Please don't stop recording.
Ma'am, can others control your recording, ma'am?
Are you getting that stop recording option there or not?
Yes, ma'am.
You are getting, no? Then you can control. All can
Oh,
control. Somebody has stopped it. It's so bad, really. I need that. I told you, and it will be useful for you people also. Please don't do like this. You know what? Yesterday, my colleagues were telling that BCA students, foreign students are there. No, they are very mischievous. So they were stopping the recording. So I felt blessed to have MCA students because no one stopped the recording. But today, even I experienced this. Okay.
Somebody might have stopped by mistake, ma'am.
Okay. Please don't do it. Yesterday two teachers complained. They said that I am starting and they are stopping. I am starting and they are stopping. Okay, tell me, you are close, Naresh. Anyone else? Next address concept.
instruction register.
Yes, somebody said. Who is it? It
Naresh,
is uh,
Naresh, ma'am, it's me.
chatting. You are only chatting with me.
No,
No, no,
ma'am.
not Naresh, not Naresh. Somebody sent me text. Who is
Program.
it?
His
Yeah.
name is not given.
Yeah, program counter, it is right. The answer is right. Very good. Give me your name. And that person has only Prem. Why you have stopped the recording? Okay, anyway, please don't. Nobody should do it. No, you have not done it. Okay, but the answer is right, Prem. It is program counter.
Holds address of holds address
Huh.
of
Yes, it holds the address of the.
instruction.
Don't cry. Don't cry. Okay, you have not done it. Don't cry. So, what happens is, um, if you can you tell me what happens at time t naught and time t1 and at time t2? At time t naught, if you remember that instruction cycle.
At time T2, it can perform decode.
Yes, very good. Time t2 we are performing decode, and
T1 and T0, at exact time T1 fetching, ma'am. Fetching the address.
means fetching means you tell me the instruction.
There are 4 points are there, ma'am. In that
Just
time,
in t naught what happens? No one remembers. AR is equal to PC. In T naught, AR is equals to PC. In T2, in T1.
In T1, memory of AR is equal to IR, instruction
Very good.
register.
Very good. And
In
comma,
in
comma.
PC
PC is equals to
IR.
PC plus 1.
PC plus 1.
Incrementing.
That is only tracking the next address.
At the time of signal 1.
Yes, at the time of timing signal 1, you are incrementing the program counter value to keep track of the next address. Yes,
At the
very good. I
time,
don't know who said, but it is right. Prem is also right. Srinivas and who said? Jagdish?
Yeah,
I
ma'am.
am.
Oh, okay. So, um, very good. Now we'll go back to this. So next address like that. You here also you should have a next address generator. What happens in next address generator? Once the present instruction is being executed, you have to generate the next address. And generation of next address is not that easy. It's not only PC equal to PC plus 1. It is also something else. Can anyone tell me something else? Does the program always execute in sequence? Yeah, fast, quick, quick. Does the program always execute in sequence? What do you mean by sequential execution of a program? Srinivas,
Sorry, ma'am, I didn't get.
what do you mean by sequential execution of a program? Okay, Prem.
Instruction one execution after another instruction.
Exactly. Execution of instructions one after the other is
Sequential.
sequential instruction. When you write programs in Java or CPP, do you write sequential programs always? Or you have some other constructs also in that? Yes, yes, fast, fast. Naresh. Students,
Sequential,
you know
not
it.
always sequential, ma'am, but
Not
sometimes we use through pointers, not in Java. In C, we use through pointers and other.
pointer is also sequential. Not pointer. Something else is non-sequential. What is non-sequential? Okay,
Uh,
Amarinder, can you tell me?
function call, ma'am.
Very good. Function call. Very good. And something else is also there. Mahesh, can you tell me?
Labels, ma'am.
Right, very good. Go to labels. Yes. And and yes, non-sequential execution function is there, label is there. Go to statements
And the loop.
very good. Looping is also non-sequential and
Control statements.
control statements like
No.
If else.
very good. If else.
While
Very
loop.
good.
The
All the
switch.
answers I got. All the answers. I'm very happy. So
Loops.
all these are non-sequential execution.
Yeah.
Remember, not always program executes sequentially. Many, programs and the real world programs in development in production, they are non-sequential. They just jump here and there. For you may get two statements for execution and then you may jump to function. Then after you resume, you come back from function, you may have if. After that, you may have loop. After that, you may have once again a function. Okay, did you get the idea?
Yeah, ma'am.
So it is all about generating the next address. So next address is not always PC is equal to PC plus 1. Okay, it is not always PC equal to PC plus 1. Only in sequential execution, it is PC equal to PC plus 1. In other cases, it is, you have to store the PC. Yesterday we studied interrupt, no? In interrupt, what happened? We stored the PC value at address 0. We store the PC value at address 0 and then we initialize PC value to 1130 something. And then we jumped to 1130 some address and then we executed and then we get back to address 0 to get the address where we have to resume the execution. Do you remember two boxes yesterday we looked at? They were divided into these units in that, some compartments kind of thing. Yes, students, please answer. Naresh, do you remember?
Somewhat, yes, ma'am.
Okay, let me quickly go back. It is not quick because it is, we have to IO programming.
Ma'am,
Okay.
we have that snap in yesterday's conversation, ma'am.
That, how can I get that?
You can
How can I
open the
get the,
yesterday's meeting. You
um,
can open the yesterday's meeting, ma'am.
I can open?
Mm,
I can get it
yeah, ma'am.
easily.
Yeah,
But
ma'am.
that home screen, it is not showing, no? Will it show the home screen? This one. Look at this one. Figure 5.14 demonstration of the interrupt cycle. If you look at here, PC after the execution of 255, PC is not executing 256 instruction. PC is not executing the instruction at 256th location. Instead, PC is jumping to 1120. So what is happening here? PC is storing the address at location 0. Which address? Where it has to come back. Because after it goes to function, when a function call occurs, then it has to jump to function, execute the function, and then resume the execution. Resume the execution in the caller procedure or a program. Yes, Naresh.
Yes, ma'am.
Prem, Srinivas, and Jagdish, and I don't know who all are there. So from that time I'm interacting with these, so I'm taking their names. It's for all the students. So did you understand this? This execution is not sequential. So remember that program will not execute sequentially always. It depends on the type of program it is. Okay. So where are we? We are studying microprogram. Here at the figure 7.1, microprogrammed control organization. So you have next address generator, that is about what I explained you just now. You have to have a logic to generate the next address. It can be the next instruction, it can be the subroutine, it can be go to, it can be any conditional statement like if, or it can be any looping structure like for or while. Next comes control address register. What happens in control address register? It is like AR register. You have address register. That address register will store the address of the instruction or data, and then using AR you read the memory content. That is here control address register does the same thing. We have a control memory. Using control address register CAR, you can read the instructions of micro instructions of control memory. Then here you have control memory, and then here you have control data register. Data register which holds the data, address register which holds the address, and here what happens is it gives the output will be the micro instruction or the control word, and also you get the information regarding the next address. The output of this whole process is to get the micro instruction as well as to get the next address information. This next address information will be fed as input, and further this information is used by next address generator to determine what is the next instruction, micro instruction that is to be executed. Is this micro programmed control unit clear?
Yes, ma'am. Somewhat, yes.
Okay. First we'll look at address sequencing. Address sequencing. So here you have um, 4 ways in which you can get the next address, or determine the next address. So just incrementing the control address register. It is this is like PC equal to PC plus 1. Means incrementing the, here PC is not there, here it is CAR, control address register. So control address register can be incremented. Okay, control address register can be incremented, and then to get the next address, to get the address of next micro instruction. And what is the difference between go to and if? Can anyone tell me what is the difference between go to and if? Quick, please quickly.
If is a selection statement and go to is jump statement.
The main difference is that in go to there is no condition given. Go to label name.
If is a conditional statement.
If is a conditional statement.
Conditional statement.
And go to is a unconditional statement. If what do you say? If within parenthesis x greater than 2 or 5 or 10, that is a condition. So that is called as a conditional statement. And unconditional means just go to label name. That is unconditional statement. So you can get the address based on whether it is conditional branch or unconditional branch. And another way is using a mapping process. Using this, what happens is from the instruction, in the instruction you get the address, and then you map it by appending or prefixing some bits to get the address. That is mapping process. The address part will be the address will be available in the instruction. To that you perform something else, some other operation to get the address. And last one is subroutine call and return. What is it like? It is like function call and return. Means just now I showed you two boxes, that is uh, where the PC is storing the address of the instruction that it has to come back and execute, and then it is jumping over and executing there, and completion of that, after completion of that it comes back and execute this. So that is facility for subroutine call and return. Okay. Conditional branching means what happens is you give the you are you able to see this?
Yes, ma'am.
Okay, first let us look at mapping. Here what happens in mapping is you get the 4-bit address, maybe this may be used as an address, and then here you are mapping 1 0 before these 4 bits and 2 zeros after these 4 bits. Then what happens? You get a 7-bit address. This is mapping, the third one. Look at this figure, this flowchart. In this flowchart, you get the instruction code. You get the instruction code. From the instruction code, you have to determine the next address. That can be done. How many ways are there? 4. What are the 4 different ways of generating next address? First one is incrementing. Second one is conditional or unconditional branch. Third one is mapping. Fourth one is subroutine call and return. So look at here, this circuit will implement, this is a sequencer. This sequencer will return what? the address. So here instruction code, and there is a mapping logic, and through mapping logic that address is given to multiplexer. And what is multiplexer? It gets n inputs and gives only one output. What inputs it is getting? If you look at this first input, it is like mapping logic. Mapping logic means what I told you, the address will be in instruction, but it will not be a complete address. To make it complete, you have to append and prefix zeros. That is mapping logic. Then you have conditional and unconditional branch. If you look at this branch logic, in this branch logic, it is getting some select bits. Suppose if based on some bits, it has to jump, it has to take a branch. So that from control memory, it gets some status bits. And then what does it do? It branch, using branch logic, you are giving it the multiplexer the next address, which is unconditional branch. No. This is conditional branch. If there is a branch logic, then it is a conditional branch. If there is no branch logic, if you are directly giving the address, it is a unconditional branch. This is unconditional branch. This is conditional branch. Then this side, this is increment the next address, and this is save and return, save and subroutine call and return. To make subroutine call and return, you have to save the address and you have to return back to the caller after the completion of the execution. So this is SPR, subroutine call and return. So this multiplexer will take all these options and decide which one to give to control address register, and based on that, control address register will give the address to control memory, and control memory will give the micro operation. So micro operation is nothing but that micro instructions will contain micro operations. So did you understand this figure, this flow chart?
Ma'am, subroutine register is a conditional statement, ma'am.
Subroutine is not conditional. Subroutine is separate. Subroutine
Okay.
register is required because when you are jumping to function, what you have to do is when you jump to function, you have to store the return address. First you
Yeah.
increment the address. If it is no SBR means subroutine call and return. That is if there is no subroutine call and return work, then incrementer is directly given to multiplexer. But suppose if it is subroutine call, then the incremented address is stored in this SBR, subroutine register, and that what happens in what happens is um, okay, subroutine register will hold the address of subroutine, and you also give the incremented address in this. Here subroutine register will give from here the address of subroutine so that the control can jump there. Okay, let me show you with pen. Here I can comment here with pen. So look at here what happens. Suppose you are here, this is one program. This is a program, and you are here, this is a subroutine. Subroutine is nothing but a procedure or a function. So you are here executing this statement. Here there is a function call. This is a function call. You are executing a function call in subroutine. When you are executing a subroutine, then what happens? Function call. What happens now? You have to jump. The control has to jump here. Before jumping, what does it do is it increments. What is this current address? Let us say it is 20. 20 is the current address. What is the next address? Next address is the 21. So you have to increment the address. This 21 you have to store where? In this subroutine, here you have to store 21. The first statement in the subroutine you have to store 21. And then this is your subroutine statements. All this you have to execute. After executing all this, you have to again jump by getting the address. Again you have to jump here. Did you understand this? So what
Yes,
happens
ma'am.
here? What happens here is in SBR, you store this return address. That is incremented value, and SBR already will have a address of this address. This here, suppose this address is 100. This the address of SBR is 100. So what is given here to multiplexer? 100. What is stored in SBR now? 21. So after execution of 100 till, suppose if it is 150, after execution of all these statements, what happens is it goes back to 21 and resume the execution. That is SBR, subroutine call and return. So this multiplexer will take from here, this is mapping logic. This is 3. And this is 4th subroutine call. This incrementing is 1. And this is 2, 2A. 2A is unconditional branch. And what is 2B? 2B is, this is 2B. 2B is conditional branch. Did you understand? Now, all this is given. From this, multiplexer will choose 1. And if it is just incrementing, then what happens? This 1 will be considered. And if there is no function call, then just the incremented address will be given. Just the incremented address. See, these 4 are there, no? Increment, unconditional, conditional.
Mapping.
Tell me. Doubt? You have a doubt? Yes, Srinivas, any doubt?
No, ma'am. Clear.
Did you understand this?
Yeah.
From out of these 4, suppose in our program, it depends on what is this instruction. If this instruction is not function call, if this instruction is not unconditional join, not join, jump, and if in this instruction is not conditional jump, if it is not mapping, then what happens? Then multiplexer will choose only increment. It all depends on what type of micro instruction is this. At address 20. At address 20, what type of instruction it is, based on that it will be decided. See, from instruction code. From this instruction code, it will be decided what has to be done. If it gets if, then it uses this. If it gets go to, then it uses this. if this statement is mapping, it uses this. If it is function, then it uses this.
Based on instruction code.
Based on instruction, it will be decided what has to be done next.
Either unconditional, either.
If suppose suppose your present instruction is if, then what has to be done? You may have to jump, no, a conditional jump. If suppose if condition is false, then you may jump to else part.
Yeah, ma'am.
So like that, it depends on instruction. So based from the instruction code only, this multiplexer will decide what is to be done. If there is a function call, obviously it has to jump to that function, no? And students, any doubt, please ask. Don't keep the doubts with you. I am here to, I'll try to clear all the doubts if I know. This micro program we will study tomorrow. So tomorrow topic of discussion will be 7.3, and that's it. I think 7.3 is only so large. So we will continue, we'll complete 7.3 tomorrow. Okay, students?
Okay,
So
ma'am.
I am
Thank you,
ending the
ma'am.
class now. I hope it is clear. Any doubt, please note down and send me. Okay? Bye bye.
Bye, ma'am.